Assalamu alaikum. This is our 22nd lecture of Managerial Economics, and the topic that we are going to cover today is linear programming. Well, linear programming is it is also called programming. The term programming is used. It has nothing to do with computer programming. When we use the term programming, it includes both linear programming and non-linear programming. But we are going to concentrate only on linear programming. Before starting the discussion, let me give you an overview of today's and subsequent lectures. The topic that we are going to cover in this linear programming problem topic, that is linear programming isocons, basic assumptions of the model, production planning for a single product, production planning for multiple products, graphic specification and solution, algebraic specification and solution, dual in linear programming, dual specification, and solving the dual problem. Let's start first of all with the linear programming isocons. Now, as far as isocons are concerned, you are quite now familiar with the term isocons because we have discussed it in detail while we were considering the topic of production, that is production analysis and estimation. Let me remind you the different types of isocons. Here you can see in this slide the different types of isocons, production isocons that we have already covered. In the upper panel on the left hand side, you can see that we have linear isocons. For linear isocons, we have said that the two factor inputs are perfect substitutes, that is, the output can be produced by using only labor, only capital, or a combination of labor and capital. Now look at the right hand side, that is the right panel of the upper panel में जो right side पे जो diagram है वहाँ पे आप देख सकते हैं जो isocons हैं they are right angled or L-shaped isocons हैं. These are also called Leontief isocons after the name of the originator of input-output analysis. तो इसको जो हमने देखा था कि यहाँ पे जो two inputs हैं they are perfect complements, they are not substitutable at all, so the substitutability in this case is equal to 0. The output can be produced at only a single point, and those points are the corner points. Okay, now coming to the lower panel, we can see the smooth isocon curves जो normal हम use करते हैं, लेकिन इसमें हमने ये कहा था that capital and labor are substitutable. Continuously they are substitutable over a certain range of the isocon, and for that range we have defined the ridge lines, upper ridge line and the lower ridge line, and we have said that economically meaningful and relevant portion of an isocon curve is the one that lies between these two ridge lines. क्योंकि हमने ये कहा था कि जहाँ पे isocon की जो slope है it becomes positive, that is economically irrelevant portion of the isocon. So, but in any case here we have assumed that the two inputs can be continuously substituted over a certain range, and that range is the negative range of the isocon curves, where the isocon curves are convex to the origin and they are negatively sloped. Now we are introducing another type of isocons which are called linear programming isocons, or they are also called activity analysis isocons. In this slide you can see these isocons which we call in linear programming isocons, और यहाँ पे आप देख सकते हैं that these isocons are not smooth isocons. These isocons are connected by linear segments. तो आप देख सकते हैं यहाँ पे हमारे पास जो isocons हैं वो हमने assume किया है कि ये यहाँ पे जो फर्म जो आउटपुट प्रोड्यूस कर रही है that is Q, and that output can be produced by using a few processes or activities. तो ये जो processes हैं these are named as process A, B, C and D, and these processes are shown by different rays from the origin जो कि point of origin से originate हो रही हैं, और इन processes में जो है इनमें से कोई एक या दो यूज़ करके जो प्रोडक्शन है वो हो सकती है. आई एम टॉकिंग अबाउट अ सिंगल प्रोडक्ट, दैट इज़ द आउटपुट ऑफ अ सिंगल प्रोडक्ट. नाउ यूटिलाइजिंग, as you can see on screen, that utilizing process A, in order to produce 1 unit of output, If we look at the process A, we can see that at point A1, the firm is using 15 units of labor and 1 unit of capital. अभी आप इसी जो process पे आप देख सकते हैं, when we move towards point A2, there the firm is using 30 units of labor and 2 units of capital, which in other words means that labor to capital ratio remains the same, that is 15:1. हमने पहले A1 पे देखा कि 15 यूनिट्स लेबर के हैं और 1 यूनिट कैपिटल का है इन ऑर्डर टू प्रोड्यूस 1 यूनिट ऑफ आउटपुट 1 क्यू. और तो यहाँ पे जो लेबर टू कैपिटल रेशियो, हम कैपिटल टू लेबर रेशियो इसलिए नहीं कह रहे कि हमने यहाँ पे जो हॉरिजॉन्टल एक्सिस है वहाँ पे कैपिटल जो है वो प्लॉट किया है और वर्टिकल एक्सिस पे लेबर को प्लॉट किया है. If we plot labor on the horizontal axis and capital on the vertical axis, तो हम कैपिटल टू लेबर रेशियो कहेंगे, लेकिन अब हम लेबर टू कैपिटल रेशियो या जो है इसकी बात कर रहे हैं. So we were saying that the firm, in order to produce 1 unit of output, that is 1 Q, it has to use 15 units of labor and 1 unit of capital. So the ratio is 15:1. Okay, this ratio along the same process will remain the same, as you can see, because we are assuming here constant returns to scale. So when the inputs are doubled, the output will also double. तो इसी रे पे आप देख सकते हैं कि A2 पे जो है फर्म 13 यूनिट्स यूज़ करेगी लेबर के और 2 यूनिट्स जो हैं वो कैपिटल के हैं. So the ratio remains the same. Ratio along the same process will remain the same, that is labor to capital ratio जो है वो उसमें कोई change नहीं आएगा. इसी तरह से आप देख सकते हैं जो दूसरे processes हैं, that is process B, process C और process D, उनकी भी हम इसी तरह से इनको भी illustrate कर सकते हैं different points को. और जब हम एक पॉइंट से दूसरे पॉइंट पे मूव करते हैं तो वहाँ पे हम assume करते हैं कि इनपुट जो है वो डबल हो जाता है और उसके जो है उसकी वजह से आउटपुट भी डबल हो जाती है. यहाँ पे डिफरेंट जो सेगमेंट्स हैं, दैट इज लाइन सेगमेंट विच इज कनेक्टिंग टू प्रोसेसेस, दैट इज लुक एट A1 एंड B1, देन B1 एंड C1, फिर C1 से D1. When we join all these linear segments, we get one isocont, and here you can see the substitutability of labor for capital or for capital for labor is limited. और यहाँ पे जो प्रोडक्शन है वो सिर्फ जो पॉइंट्स किंक्स हैं, यहाँ पे शार्प कॉर्नर्स हैं, वहाँ पे हम अस्यूम करते हैं कि फर्म जो है वो प्रोड्यूस कर रही है. एज फार एज दिस फर्स्ट आइसोकॉन्ट इज कंसर्न, दिस इज प्रोड्यूसिंग 1 यूनिट ऑफ आउटपुट. 1 आप कह सकते हैं या 100 कह सकते हैं, 1000 कह सकते हैं, whatever, but in any case the next higher isocont is it is presenting 2 units of output, फिर 3 units of output and so on. So higher जो isoconts हैं वहाँ पे आप देख सकते हैं level of output will be increasing as we move upward to the right. All right, here we have a map of isoconts which are linear programming isoconts, and here the substitutability of the 2 factors of production is limited. और यहाँ पे आप देख सकते हैं कि जो different line segments हैं, that is A1, B1, इसी तरह से A2, B2 and A3, B3, these are parallel to each other. अब इसमें जो है ये आइसोकॉन्ट्स मैंने जैसे पहले कहा कि लीनियर प्रोग्रामिंग में इस टाइप के आइसोकॉन्ट्स जो हैं यूज़ होते हैं और इनको इसीलिए लीनियर प्रोग्रामिंग आइसोकॉन्ट्स कहा जाता है. यहाँ पे अब नेक्स्ट हमने देखा था कि जब हमने प्रोडक्शन एनालिसिस में आइसोकॉन्ट्स को डिस्कस किया था, देन वी हैव मूव्ड ऑन टू द लीस्ट कॉस्ट कॉम्बिनेशन, दैट इज़ द ऑप्टिमल कॉम्बिनेशन ऑफ द 2 inputs, and there we have incorporated the isocost lines. In the next slide we are going to incorporate into this diagram the isocost line, and we have to see that the tangency between the isocont curve and the isocost curve, that will determine the optimal level of output. Optimal level of output, that is by using an optimal combination. Here we can see that the optimum level of output, that is Q equal to 3, it is produced by using the optimal combination which is at point B3, that is the point of tangency between the isocost curve and the isocont Q equal to 3, and this is point B3. Here the firm is using 30 units of labor and 6 units of capital. So as we have seen that in case of process B, the ratio of labor to capital is 5. Look at, in the previous slide we have seen that at B1 the firm was using 10 units of labor and 2 units of capital, whereas at B2 it was using 20 units of labor and 4 units of capital, and at B3 it is utilizing 30 units of labor and 6 units of capital. So for all of these points, that is B1, B2, B3, the ratio of labor to capital remains the same, that is 5 to 1. And here the firm is using 30 units of labor and 6 units of capital. This is the least cost combination. This means that from these processes, that is process A, process B, and C and D, process B is the one which is giving the firm the least cost combination or least cost production. We introduced in the next slide another type of constraint, and that is the constraint on the availability of capital and labor. So here in this diagram we can see that the firm has only 11 units of capital and 20 units of labor. So these constraints are shown in the diagram. As you can see that here the firm को जो available है resources, यहाँ पे capital जो है that is equal to 11 units and labor is equal to 20 units. So these are new constraints, but the firm has already the constraints in the form of production possibilities जो कि हमने बताए थे process 1 में, process 2, 3, 4, these are also constraints, क्योंकि फर्म जो है वो इन्हीं प्रोसेसेस को यूज़ करते हुए प्रोडक्शन जो है वो उसके लिए पॉसिबल है. अभी जो हमने आइसोकॉन्ट्स, जो स्मूथ आइसोकॉन्ट्स जो हमने पहले डिस्कस किए थे, उसमें हमने जो स्मूथनेस है कर्व की वो इसलिए अस्यूम की थी कि हमने ये कहा था कि कंटिन्यूस सब्स्टिट्यूशन है. यहाँ पे सब्स्टिट्यूशन ऑफ लेबर फॉर कैपिटल, दिस इज़ नॉट कंटिन्यूस, इट इज़ लिमिटेड. ये लिमिटेड है, और लिमिटेड इसलिए है कि यहाँ पे सर्टेन प्रोसेसेस हैं जिनको यूज़ करते हुए फर्म जो है वो प्रोडक्शन कर सकती है. और ये जो प्रोसेसेस हैं, इफ़ द नंबर ऑफ दीज प्रोसेसेस इज़ इंक्रीज्ड इन्फिनिटली, only then we can say that this isocont, which is an isocont which has sharp kinks, it will approach the smooth isocont. और वहाँ पे smooth isocont जो थे classical analysis में हमने इसलिए assume किए थे that they are easy to handle, in the sense that we can use calculus there, and it was assumed that the smooth isoconts are continuous and differentiable everywhere. लेकिन यहाँ पे आप देख सकते हैं कि हम इनको डिफ्रेंशिएट नहीं कर सकते. वाई? द रीज़न इज़ दैट दीज आइसोकॉन्ट्स आर नॉट स्मूथ आइसोकॉन्ट्स. और डिफ्रेंशिएबिलिटी के लिए जो हमारे पास कंडीशन है, इट्स नॉट जस्ट द कंटिन्यूटी ऑफ अ फंक्शन बट ऑल्सो दैट द फंक्शन शुड बी स्मूथ. But in this case, the function or these isoconts are not smooth isoconts. तो अगर हम एक जो sharp corner है उसके ऊपर अगर हम एक tangent draw करेंगे, this will not be a unique tangent, क्योंकि हम different tangents जो हैं एक sharp corner पे different slopes के साथ उसको draw कर सकते हैं. Therefore, we can say that these isoconts, that is the linear programming isoconts, they are not differentiable. तो इस तरह से अगर हम नंबर जो है इन प्रोसेसेस का वो इंक्रीज कर दें, दैट इज़ इन द लिमिट वी कैन से दैट द नंबर ऑफ प्रोसेसेस इज इंक्रीज्ड टू एन इन्फिनिट नंबर, देन ओनली देन वी कैन से दैट दीज linear programming isoconts will be approaching the continuous and the smooth isoconts. In this case, we can see that there are the constraints. The firm that is facing the constraint, one is the availability of labor and capital, and the other constraint is these processes. जो processes हमने बताए हैं या जिनको activities भी कहते हैं कि activity A, B, C and D. So firm के लिए ये भी constraints हैं. Now looking at these two types of constraints, that is the constraints of the inputs and also the activities that the firm can utilize. तो इसमें हम देख सकते हैं कि firm का जो feasible region है, जो फर्म के पास यहाँ पे कंस्ट्रेंट आएगा, वो हमने यहाँ पे डायग्राम में आपको शो करके बताया है, जो कि शेडेड एरिया से आप देख सकते हैं. और इसी को हम फिर आगे चलकर जब हम लीनियर प्रोग्रामिंग प्रॉब्लम लेके आएंगे तो उसमें हम इसको फिर डिटेल में डिस्कस करेंगे, हाउ डू वी फाइंड दिस फीजिबल रीजन और विच इज़ ऑल्सो कॉल्ड फीजिबल स्पेस। तो इसमें रहते हुए फर्म जो है उसको प्रोडक्शन जो है यहाँ पे करनी है। अब यहाँ पे हम आइसोकॉन्ट्स जो हैं इनको हम यूटिलाइज करेंगे। ये जो नॉलेज है किंक्ड आइसोकॉन्ट्स की या जो शॉर्प कॉर्नर के साथ आइसोकॉन्ट्स हैं, इनको हम यूटिलाइज करेंगे अपने इन लेक्चर्स में। लेकिन उससे पहले अब हम जो है लीनियर प्रोग्रामिंग प्रॉब्लम जो है उसके ऊपर आते हैं। Linear programming problem, it can be defined as a model consisting of linear relationships representing a firm's objective and resource constraints. Linear programming is a mathematical modeling technique used to determine a level of operational activity in order to achieve an objective subject to restrictions called constraints. So, इस definition को जब हम देखते हैं, in this definition we have used some terms which is the objective and then the constraints. We are already familiar with these terms in the sense that we have already discussed optimization without constraints and with constraints. तो उसमें जो classical हमने method use किया था, we have there used differential calculus and also the Lagrangian multiplier method. तो उसमें भी हमने constraint optimization को discuss किया था. We have discussed both the constraint maximization problem and constraint minimization problem. The difference here is that we are again optimizing a constraint problem, but the difference is that here we are using a set of constraints. Instead of only one constraint, we are using a set of constraint as far as the objective function is concerned. Objective function जो है उसको जिस तरह से पहले आप फर्म का हम कहते थे, देयर इज अ गोल ऑफ द फर्म दैट इट वांट्स टू मैक्सिमाइज इट्स प्रॉफिट्स और इट्स ड्यूअल प्रॉब्लम इज इट वांट्स टू मिनिमाइज इट्स कॉस्ट्स। तो ऑब्जेक्टिव जो है वो फर्म का वही है। द ऑब्जेक्टिव फंक्शन एज फार एज द डेफिनेशन or the concept of objective function is concerned, it is the same. The only difference here is that instead of using one constraint, we are using more than one constraint. वहाँ पे भी हम more than one constraint जो है वो use कर सकते हैं, लेकिन हमने वहाँ पे ये जो है employ नहीं किया था. We have just considered a constraint optimization problem using using an objective function. That is, the objective function was to be maximized or minimized subject to one constraint only. When we compare these two methods or techniques, we can see that the objective of the two techniques is the same, that is to maximize or minimize a function. तो जो फ़र्क है वो जैसे मैंने पहले कहा कि objective जो है वो वही है, but the difference here is that we are going to use a set of constraints. और जो set of constraints है, those are not equations. We are going to use linear inequalities. तो यहाँ पे ये फ़र्क जो है सबसे ज़्यादा इम्पॉर्टेंट है कि in case of classical analysis we have seen that there was just one constraint. वहाँ पे हम constraint और use कर सकते थे, ये नहीं है कि हम नहीं use कर सकते थे, लेकिन हमने एक ही constraint जो था वो use किया था और वो भी equation की form में था. जबकि यहाँ पे जो हमारे constraints हैं वो inequality की form में हैं और इनको linear inequalities कहते हैं because we are going to use linear inequalities. Well, when we introduce these inequalities into our subject here, that makes the problem at once more interesting and more realistic. In the sense, जैसे कि हम example ले सकते हैं कि वहाँ पे जब हम consumer theory में देखते हैं तो consumer theory में हम ये assume करते हैं कि let's say एक consumer है और उसकी income जो है weekly 1000 rupees है. तो वहाँ पे जो उसका constraint है that is strictly in the form of an equation. हम ये कह रहे हैं कि पर वीक उसकी जो इनकम है दैट इज़ इक्वल टू 1000 रुपीज़. तो लेकिन जब हम यही बात जो है लीनियर प्रोग्रामिंग में एक्सप्लेन करेंगे तो उसमें फिर उसकी फॉर्म जो है वो लीनियर इनइक्वालिटी की फॉर्म में आ जाएगी. दैट इज़ द कंज्यूमर कैन स्पेंड दिस इनकम एग्जैक्टली 1000 रुपीज़ और लेस देन 1000 रुपीज़, जो कि ज़्यादा रियलिस्टिक है क्योंकि ज़रूरी नहीं कि 1000 रुपीज़ अगर उसकी इनकम है तो वो सारी जो है वो 1 वीक में कंज्यूम कर ले. ये भी हो सकता है कि वो उससे कम जो है उसको स्पेंड करे, क्योंकि हम ये रिस्ट्रिक्शन लगा रहे हैं इट इज़ इक्वल टू और लेस देन. सो ही कैन नॉट ओवर स्पेंड, दैट इज़ ही कैन नॉट स्पेंड more than 1000 rupees, but he can spend either equal to exactly 1000 rupees or less than 1000 rupees. रियल लाइफ में तो ये भी है कि वो बोरो भी कर सकता है, ओवर स्पेंड कर सकता है 1000 रुपीज़ में, लेकिन हम एस्यूम कर रहे हैं कि यहाँ पे जो लिमिटेशन है इनकम की वो उसको स्ट्रिक्टली फॉलो करेगा और उससे ओवर स्पेंड, उससे ज़्यादा वो स्पेंड नहीं कर सकता. इसी तरह से फर्म जो है उसके लिए हम जो है एक जो यहाँ पे रिस्ट्रेंट्स होंगे, जो कंस्ट्रेंट्स होंगे, दोज विल बी फॉर द मैक्सिमाइजेशन प्रॉब्लम, दे विल बी ऑफ द फॉर्म equal to or less than, or and for the minimization problem the set of constraints will be of the form equal to or greater than. तो इसको हम डिटेल में बाद में एक्सप्लेन करते हैं. इससे पहले जो लीनियर प्रोग्रामिंग है उसकी जो हिस्टोरिकल पर्सपेक्टिव है, in that we can see that the founders of this concept are Leonid Kantorowicz, a Russian mathematician who developed linear programming problem in 1939. Later on, George B. Dancing published the simplex method in 1947, and John von Neumann, who developed the theory of duality in the same year. So 1939 में रशियन मैथमेटिशियन ने इसको सबसे पहले जो था प्रेजेंट किया लीनियर प्रोग्रामिंग को, और इसके बाद लेटर ऑन डैंसिग ने जो है सिम्प्लेक्स मेथड को डेवलप किया और जॉन वन न्यूमैन ने ड्युअलिटी थ्योरी को इंट्रोड्यूस किया. नाउ वी आर गोइंग टू इंट्रोड्यूस लीनियर प्रोग्रामिंग फॉर्मली. A linear programming model seeks to maximize or minimize a linear function subject to a set of linear constraints. The linear model consists of the following components. Number one is a set of decision variables. Number two, an objective function. And number three, a set of constraints. We call it a linear programming, as I have already said that we can use the term programming which includes both linear programming and non-linear programming, लेकिन हम सिर्फ linear programming पे concentrate करेंगे. And it is called linear programming because all the functions which are involved here, that is the objective function, the set of constraints, these are all linear. और इसकी जो assumptions हैं उसकी वजह से हम ये assume करते हैं कि यहाँ पे जब भी इनमें increase होगी या decrease होगी in these function, it will be in a linear fashion. So the objective function, यहाँ पे जो इसके components हैं वो decision variables हैं. The first component is the objective function, और objective function में जो decision variables हैं वो हैं, those decision variables could be 2 or more than 2. If the number is 2, then we can use the geometrical method or the graphical method. But if the number of these variables is more than 2, in that case it will become very difficult to use the graphical method, क्योंकि वहाँ पे जो है 3-dimensional diagram जो है उसको handle करना बहुत मुश्किल हो जाता है. इसलिए जब हमारे पास decision variables जो हैं they are equal to 2, then we can easily use this graphical method. Otherwise फिर इसके लिए जो simplex method अभी मैंने mention किया, simplex method जो है वो use किया जाता है, या फिर computer softwares जो हैं ज़्यादातर उनको use किया जाता है, क्योंकि linear programming problems जो हैं they are quite tedious and lengthy in calculations. Therefore in real life normally they are not solved by hand, तो उनको manually हम solve नहीं करते. linear programming जो इसकी application बहुत extensive है. हम देख सकते हैं कि इसको हम यूज़ कर सकते हैं प्रोडक्शन में, मैन्युफैक्चरिंग में, और इसके अलावा मार्केटिंग में, एडवर्टाइजिंग में, और इसका बहुत एक्सटेंसिव यूज़ जो है शुरू में वर्ल्ड वॉर 2 के ज़माने में मिलिट्री के ऑपरेशंस में भी इसको बहुत ज़्यादा यूज़ किया जाता रहा है. बेसिकली वील बी कंसिडरिंग अ मैक्सिमाइजेशन प्रॉब्लम टुडे. सो लेट्स सी इन जनरल हाउ वी कैन explain this profit maximization problem, and then we will use a specific example for this purpose. Profit maximization problem using linear programming. Constraints of production: capacity, time, money, raw material, budget, space, and other restriction choices. These constraints can be viewed as inequality constraints. A linear programming problem assumes a linear objective function and a series of linear inequality constraints. Linearity implies that constant prices for output, as in a perfectly competitive market. Number 2, constant returns to scale for a production process. Number 3, typically each decision variable also has a non-negativity constraint. For example, the time spent using a machine cannot be negative. और इसके अलावा सोल्यूशन मेथड्स, अभी मैं इन पॉइंट्स को दोबारा एक्सप्लेन करती हूँ. सोल्यूशन मेथड्स की जब मैंने बात की थी, आई हैव सेड दैट लीनियर प्रोग्रामिंग प्रॉब्लम कैन बी सॉल्व्ड यूजिंग ग्राफिकल टेक्निक्स, एल्गोरिथम, यूजिंग मैट्रिसेस और यूजिंग सॉफ्टवेयर सच एज फॉर प्रॉफिट सॉफ्टवेयर, Lindo, MS Excel solver. In the graphical technique, I have said that if there are two variables, we can easily use graphical technique, but otherwise if there are more than two decision variables, we will not be able to use this technique. और थर्ड जो मैंने अभी कही है, सिंप्लेक्स मेथड से हम इसको सॉल्व कर सकते हैं. और इसके अलावा जो हमारे पास ऑप्टिमल फीजिबल सोल्यूशन है, दैट अकर्स अलोंग द बाउंड्री ऑफ द फीजिबल सोल्यूशन स्पेस एट द एक्सट्रीम पॉइंट्स और कॉर्नर पॉइंट्स. Assumption of the linear programming model includes the parameter values are known with certainty. That is, we know what will be the profit contribution of a particular product, and similarly we also know definitely कि कितने जो units हैं एक input के वो use होंगे in order to produce one unit of a particular product. The second assumption is that the objective function and the constraints exhibit constant returns to scale. There are no interaction between the decision variables, that is, the additivity assumption is included here. The continuity assumption, variables can take on any value within a given feasible range. तो जो basic assumptions हैं, जैसे कि मैंने पहले कहा कि basic assumptions are that the objective function is linear and we have a set of linear inequalities constraints है, और इसके अलावा non-negativity constraint है. तो इसमें हमने जो डिफरेंट जो असम्पशंस अभी आपको बताए हैं, लिनियरिटी की जो है उसकी वजह से, बिकॉज वी आर अस्यूमिंग दैट द ऑब्जेक्टिव फंक्शन इज लीनियर एंड द सेट ऑफ कंस्ट्रेंट इज आल्सो अ सेट ऑफ लीनियर इनइक्वालिटीज. तो इस वजह से लिनियरिटी जो है उसकी वजह से हम ये फर्दर हमारे पास जो असम्पशंस हैं वो ये हैं दैट द इनपुट प्राइसेस आर फिक्स, दैट इज दे आर कांस्टेंट. आउटपुट प्राइस जो है वो भी कांस्टेंट है, और इसके अलावा हम ये अस्यूम करते हैं दैट देयर आर कांस्टेंट रिटर्न्स टू स्केल. और इस तरह से हमने जो इसके डिफरेंट कंपोनेंट्स एक्सप्लेन किए हैं, दैट इज द ऑब्जेक्टिव फंक्शन, सेट ऑफ इनइक्वालिटी कंस्ट्रेंट्स एंड नॉन नेगेटिविटी कंस्ट्रेंट्स. व्हाट डू वी मीन बाय नॉन नेगेटिविटी कंस्ट्रेंट? ये लीनियर प्रोग्रामिंग इज मैथमेटिकल टूल in order to maximize or minimize a function. So it's quite possible that as a result of solving this problem, we might get the solution such as कि हमारे पास कोई negative quantities आ जाती हैं. But in economics we are not talking about the negative inputs or negative outputs. So in order to find an economically feasible solution, we impose this restriction of non-negativity. That is why when we use the graphical method, we restrict ourselves to the positive quadrant only. क्योंकि हम ये assume कर रहे हैं that the decision variables are equal to or greater than 0. In other words, they are positive. Steps in developing a linear programming model are: number 1, the formulation of the problem; number 2, solution of the problem; and number 3, interpretation and sensitivity analysis. As far as the general formulation of the problem is concerned, first we will consider a maximization problem. We have a linear function to be maximized, that is the objective function maximized by profit is equal to C1 x1 plus C2 x2, subject to the inequality constraint. The first constraint is A11 x1 plus A12 x2 less than or equal to B1. The second constraint is A21 x1 plus A22 x2 is equal to or less than B2, and the third constraint is A31 x1 plus A32 x2 is equal to or less than B3, and the non-negativity constraints are x1, x2 are both positive, that is they are equal to or greater than 0. So in this case you are quite familiar with the objective function, and as far as the non-negativity constraint is concerned, that is also quite clear. Now look at the set of inequality constraints. There we have certain constraints. अगर हम इसको इस तरह से सोचें कि फर्म जो है वो मैक्सिमाइज करना चाह रही है प्रॉफिट को सब्जेक्ट टू द अवेलेबिलिटी ऑफ इनपुट्स. लेट्स से द फर्स्ट इनपुट, द फर्स्ट कंस्ट्रेंट indicates the constraint on the first input. Second, फिर हमारे पास एक और इनपुट है, लेट्स से लेबर, कैपिटल, रॉ मटेरियल्स. इस तरह से हम इसको एक्सप्लेन कर सकते हैं. So the available amount of the first resource is B1. The firm can use B1 exactly or less than B1. Similarly, जो second constraint है that is on input and on the second input या हमारे पास जो resource है firm के पास वो उसको utilize कर सकती है exactly equal to B2 or less than B2. And similarly for the third constraint the illustration is the same. अब ये प्रॉब्लम है जिसको हम पहले फॉर्मुलेट करते हैं. हमारे पास एक प्रॉब्लम स्टेटमेंट जो है वो दी जाती है. वी हैव टू लुक एट दिस प्रॉब्लम स्टेटमेंट केयरफुली and then we have to formulate our problem in this format. First of all, we have to specify the objective function, then we have to specify the set of linear inequalities and then non-negativity constraint. As far as the general formulation of the linear programming problem, that is a minimization problem is concerned, you can see it on screen that it is just the same. जो objective function है that is linear और इसके बाद linear inequality constraints हैं. Here you can see the difference. The difference is that in case of maximization problem, the inequality constraint was expressed in the form equal to or less than. But here you can see the constraints are in the form of linear inequalities, but the direction of the inequality is different. That is, now we are expressing our constraint as equal to or greater than. So यहाँ पे this is the basic difference between a linear programming maximization problem and a linear programming problem minimization problem. तो इसमें जो बाकी आप देख सकते हैं कि objective function is the same यहाँ पे, लेकिन objective function वहाँ पे we have to maximize it. Here the objective function is to be minimized. Whereas जो यहाँ पे linear inequality constraints हैं उनका जो format है वो different है. The inequalities are used in both of these cases, but in case of maximization the inequalities of the form equal to or less than, but here the inequalities of the form equal to or greater than, or non-negativity constraint, they are the same. Now these general formulation of the linear programming problem, they can also be expressed in a more compact form using matrices. That is, we can use here, we can express our objective function, you can see it on screen, which is given as maximize C T x, where C is represents the coefficients of objective function, and we have to take the transpose of that, where x is the column vector of unknowns and subject to the constraint Ax equal to or less than B, where A is the coefficient matrix and x is the column vector of unknowns and B is the column vector of constants. The non-negativity constraints are again expressed in the form of x greater than or equal to 0. यहाँ पे x जो है that is representing the column vector of unknowns, that is the decision variables which are to be maximized or minimized. Similarly, the compact form of minimization problem can also be, you can see here only the difference is that here the constraints are in the form Ax is equal to or greater than B, where A is the coefficient matrix, x is the column vector of decision variables and B is the column vector of constants. Now in order to find the graphical solution of a linear programming problem, the steps that we have to take are, number one is we have to plot model constraints on a set of coordinates in a plane. Number two, we identify the feasible solution space on the graph where all constraints are satisfied simultaneously. And number three, we plot objective function to find the point on boundary of the space that maximize or minimize values of objective function. अब इसके लिए हम एक न्यूमेरिकल एग्जाम्पल जो है वो आपको लेंगे और इसको सारे जो प्रोसीजर को डिफरेंट स्टेप्स हैं उनको एक्सप्लेन करें. लेकिन इससे पहले एक आपको जो है इसका आइडिया देने के लिए हमने पहले आपको ग्राफ जो हैं डिफरेंट ग्राफ्स जो हैं उसके ज़रिए मैं आपको ये बताऊंगी और इसके बाद नेक्स्ट जो है हम एक न्यूमेरिकल एग्जाम्पल के साथ इस सारे प्रोसीजर को एक्सप्लेन करेंगे. नाउ फर्स्ट ऑफ ऑल हमने ये कहा द फर्स्ट स्टेप इज़ टू प्लॉट द constraints. The constraints here are in the form of an inequality, but we will assume हम इसको जब प्लॉट करेंगे तो वो हम एक इक्वेशन के फॉर्म में उसको प्लॉट करेंगे. तो यहाँ पे आप देख सकते हैं कि assuming that we only have two constraints, so we plot the first constraint. आप इसको स्क्रीन पे देख सकते हैं कि फर्स्ट कंस्ट्रेंट को हम इस तरह से प्लॉट करेंगे. Since the constraints are in the form equal to or less than, तो इसके लिए जो हम, क्योंकि पहले हम मैक्सिमाइजेशन प्रॉब्लम को कंसिडर कर रहे हैं, तो यहाँ पे जो आपके पास ये जो सोल्यूशन है इसका स्पेस जो फीजिबल रीजन होगा दैट विल बी ऑन द कंस्ट्रेंट इक्वेशन एंड टुवर्ड्स द लेफ्ट ऑफ द कंस्ट्रेंट। यहाँ पे इसको हम आगे चल के एक्सप्लेन कर सकते हैं, करते हैं। अभी हम आपको क्विकली इन जो है डिफरेंट डायग्राम्स के ज़रिए सिर्फ आपको एक आइडिया जो है वो देते हैं कि किस तरह से हमने इनको प्लॉट करना है। अब सेकंड जो स्क्रीन है, अगर हमने पहला कंस्ट्रेंट जो है वो प्लॉट कर लिया है और यहाँ पे आप देख सकते हैं कि हमने इस एरिया को शेड किया है, दैट इज़ द area which is shaded, it is the feasible region. Next we plot the second constraint, you can see it on the screen. और इसके बाद next diagram में आप देख सकते हैं कि that we have plotted both of these constraints. Step by step पहले हम एक constraint को plot करते हैं, फिर दूसरे को plot करते हैं, and then you can see that now the area that is satisfying both of these constraints that is shown by the shaded area, which is called the feasible region or feasible space. In the next slide, you can see that we have here incorporated the isoprofit lines because basically the problem here is to maximize profit. तो हमने यहाँ पे isoprofit lines जो हैं उनकी इनको incorporate किया है. You can see a series of isoprofit lines which are negatively sloped and they are linear because we have said that we are assuming linear objective function. So we have incorporated into this diagram the objective function. You can see here the objective function and also the feasible region. In the next diagram, we can see that here the feasible region has different corner points. In this case, there are as many as 4 corner points. एक तो आपका पॉइंट ऑफ ऑरिजिन है और इसके बाद नेक्स्ट आप देख सकते हैं इट इज़ द इंटरसेक्शन ऑफ वन ऑफ द एक्सिस एंड वन ऑफ द कंस्ट्रेंट्स, देन द इंटरसेक्शन ऑफ द टू कंस्ट्रेंट्स, एंड yet we have another point which is the intersection of y axis and one of the constraints. So यहाँ पे जहाँ पे भी intersection है, intersection of any two constraints or intersection of one of the axis and the constraint, there we can see a corner point, a sharp point. तो इस पॉइंट्स पे यहाँ पे जो हमारे पास feasible region है that includes this shaded area and the boundary of this shaded area, which is जो हमने यहाँ पे जो बाउंड्री है इस शेडेड एरिया की that is also included in the feasible region. अब यहाँ पे आप देख सकते हैं कि पॉइंट B जो है उस पे एक कॉर्नर पॉइंट है that is the intersection of, that is the result of an intersection of the two constraints, and one of the highest possible isoprofit line is tangent to this corner point. So that is the optimal solution of this problem which we have obtained graphically. लेकिन इसको हमने जो है आपको जनरली आइडिया करने के लिए इसको हमने डिफरेंट ग्राफ्स जो थे वो बनाए हुए थे और आपको बताया है कि हमने किस तरह से इस प्रोसीजर को जो है करना है फॉलो. फर्स्ट ऑफ ऑल, नॉन नेगेटिविटी कंस्ट्रेंट की वजह से वी हैव टू रिस्ट्रिक्ट आवरसेल्व्स टू द पॉजिटिव क्वाड्रेंट, और इसके बाद हमने हमारा पहला स्टेप जो था वी हैव प्लॉटेड द कंस्ट्रेंट्स, फर्स्ट कंस्ट्रेंट, सेकंड कंस्ट्रेंट, एंड देन we have shaded the area which satisfy both of these constraints. Okay, and the next step is to incorporate the objective function. फिर इसके बाद objective function जो था that is a profit function, and we have drawn a series of isoprofit lines in order to incorporate the objective function into the picture. And then we have said that the solution, the optimal solution is one of the corner points. That is the boundary line of this feasible region and the shaded area which satisfy both of these constraints, and one of the corner points is the optimal solution, the possible optimal solution, and this will be the optimal solution which gives the firm the highest profit and it is tangent to the highest isoprofit line. तो इस तरह से ग्राफिकली हम इसको सॉल्व करते हैं. अब नेक्स्ट हम एक एग्जाम्पल जो है न्यूमेरिकल आपके सामने जो है उसको इसी तरह से स्टेप बाय स्टेप सॉल्व करते हैं ताकि ये क्लियर हो जाए आप पे. नाउ कंसिडर अ फर्म विच इज प्रोड्यूसिंग टू प्रोडक्ट्स दैट इज एक्स एंड वाई, and it has 3 inputs at its disposal, that is input A, input B and C. Now look at the slide. You can see in this table that this information is given that the firm has three inputs A, B and C, और इसके लिए the product that it is producing are X and Y. The information which is given here is, as far as the objective function is concerned, we are given the information that is the per unit profit contribution of product X is $12 and per unit profit contribution of product Y is $9. Obviously, the profit contribution is the difference between the price of the commodity and the average cost of the commodity. So it is the excess of price charged by the firm over the average cost of the firm. तो हम ये assume कर रहे हैं कि $12 एक जो यूनिट है X का, commodity X का, that is giving $12 profit to the per unit profit to the firm, और जो product Y है उसका जो profit per unit है that is $9 per period. So that we can specify first of all our objective function. In order to specify the objective function, we are given the information that in order to produce 1 unit, the profit per unit of X is $12. So we multiply 12 by X, where 12X, where profit per unit is $12 and X is the number of units produced and sold of X, plus the profit margin of product Y, which is $9, multiplied by the number of units produced and sold of Y, so that the profit function can be written as a sum of these products, that is Y is equal to 12X plus 9Y. Now next we have to consider the specification of the inequality constraints, and for this purpose you can see on slide this table is given for the specification of these constraints, and the information that is provided is that the firm has three inputs, that is A, B and C, and the quantity available of these inputs is A is 32 units, B 10 units and C 21 units. In order to produce 1 unit of product X, it uses 4 units of input A, and in order to produce 1 unit of product Y, it uses 2 units of input A. So that the first constraint can be written as 4X plus 2Y is equal to or less than 32. On the right hand side, we have this constant which is equal to 32, which means that अगर हम ये assume करें that these 32 units are the labor hours, then we can say that the firm can use these 32 hours exactly or less than 32 hours. तो इसके लिए हमारे पास जो information है कि input A के 4 units चाहिए X को produce करने के लिए and 2 units are required to produce 1 unit of Y, so that our first constraint can be written as 4X plus 2Y is equal to or less than 32 units. The total available units of input A are 32. Similarly, we can construct our second constraint. Look at the table here. The information is provided that B is the total units available of input B are equal to 10 units, and in order to produce 1 unit of X, it requires 1 unit of input B, and similarly Y also needs 1 unit of input B, so that we can write here the second constraint, 1X plus 1Y is equal to or less than 10 units. अब 1x 1y की बजाय हम लिख सकते हैं x plus y is equal to or less than 10 units. Now, as far as the third input is concerned, that is input C. Input C में आप यहाँ पे टेबल में देख सकते हैं that the total quantity available is 21 units. And as far as the production of X is concerned, no unit of this input C is required. That is, production of X is not constrained by input C, since it is not required in the production of X. 3 units of input C are required in order to produce 1 unit of Y, so that our third constraint can be written as 3Y is equal to or less than 21. Now, the problem that we have formulated from the given information, you can see on the screen here that we have specified our objective function pi is equal to 12x plus 9y, that is the function which is to be maximized. Subject to the inequality constraints, input A, the constraint for input A is 4x plus 2y equal to or less than 32. Input B, x plus y less than or equal to 10. And input C, 3y less than or equal to 21. And the non-negativity constraint, x and y are both non-negative, that is they are equal to or greater than 0. We have said that the first step that we have to take here is to plot the constraints. और constraints को plot करने के लिए the first constraint here is 4x plus 2y less than or equal to 32. तो जो constraint है हमारे पास उसको हम plot करने के लिए ज़ाहिर है equation form में it is 4x plus 2y equal to 32. We plot this. How do we plot it? It's easy because it is linear and we need just 2 points on the line. And these two points can easily be found. First of all, we set x equal to 0 in order to find the y-intercept, and then y equal to 0 in order to find x-intercept. That is assuming that the firm is producing only y. In that case, the firm can produce, if we set x equal to 0, the firm can produce, if we set x equal to 0, then we have 2y equal to 32, so that y is equal to 16. If the firm produces only product y, it can produce 16 units of y as far as this first constraint is concerned. On the other hand, if the firm produces only x, then in that case we set y equal to 0 and we have 4x is equal to 32, so that firm can produce 8 units using this constraint. Firm can produce only 8 units of x if no unit of y is produced. By joining these 2 points, we can easily plot our constraint, which is 4x plus 2y is equal to 32. This constraint divides the xy plane into 2 half spaces. और यहाँ पे हम देख सकते हैं कि ये जो इसने divide किया है, that is the line itself, that is the constraint line, and the area which lies towards the left of this, and the area which lies towards the right of it. The constraint line and the area, or the points that lie towards the left of this line, are satisfying this constraint because the constraint is of the form equal to or less than. The points which lies to the right of this constraint are violating this constraint because we have expressed our constraint in the form equal to less than. तो अगर हम right side पे जो points हैं उनको consider करेंगे, those are the points which are indicating the points which are greater than 32. So these are violating our constraint. Therefore, the constraint in this case, our feasible space or feasible region is this constraint line and all those points which lies below this constraint, and they are shown by the shaded area. The next step is, now this is the first step, and in this step we have to plot all the constraints. We have already plotted the first constraint. Now in the next diagram you can see that we have plotted the remaining 2 constraints, that is constraint which is imposed by input B and the other one, that is the third one, which is imposed by input C. And in this case you can see the shaded area which is satisfying all 3 constraints, and this is the feasible region or feasible space. Feasible space is the region or area which satisfies all the 3 constraints. In this case, since we have 3 constraints, so the area which satisfies all 3 constraints is the area which is the feasible area or feasible region. With that, we come to end of today's lecture. We'll continue with this next time. Thank you. Khuda Hafiz.